Welcome to today's lesson where I'm covering Introduction to Unsupervised Machine Learning. I'll be walking you through the following subtopics. That's the definition of unsupervised learning. We will look at main types of unsupervised machine learning, clustering, dimensionality reduction, association rule mining, and then we will also consider the application of unsupervised machine learning in real life, and then we conclude our lesson. What is unsupervised learning? Unsupervised learning is a type of machine learning that discovers patterns from data without labeled outputs. It is used to find structures, groupings, or relationships in input data. The key goals of unsupervised learning include finding clusters or groups in a dataset which are similar, reduce dimensionality for easier analysis, detection of anomalies in the dataset, or discovery of latent structures in the dataset. There are three main types of unsupervised machine learning, and these are clustering, dimensionality reduction, and association rule mining. The clustering is an unsupervised learning technique used to group similar data points into clusters. It identifies natural groupings within a dataset without needing predefined labels. There are five main clustering algorithms, and these are k-means clustering, hierarchical clustering, db-scan, density-based spatial clustering, mean-shift clustering, and Gaussian mixture models. The k-means clustering, it works by dividing data into k-clustering. Each data point is assigned to the cluster with the nearest mean. Example of use cases include cluster segmentation by buying behavior, grouping students by performance. The hierarchical clustering algorithm, it works by building tree-like structures, which are called dendrograms. This can be done as an agglomerative, that's from bottom up, or divisive, from top down. Example cases include organizing documents by topic or in gene expression pattern analysis in biology. Then we have the db-scan, which is density-based spatial clustering. And this works by grouping together closely pegged points. Points in low density regions are considered outliers. Examples of use cases include detecting noise and anomalies in sensor data, identifying clusters of users in social networks. The mean shift clustering algorithm, it actually works by iteratively shifting data points towards the mode. Example use cases include image segmentation, tracking moving objects in videos. Then we have the Gaussian mixture models. This works by assuming that data is generated from a mixture of several Gaussian distribution. Example use cases include soft clustering of documents, speech recognition. There are a number of advantages of clustering, and these are discovery of hidden patterns, and we have the data summarization and simplification, customer segmentation and personalization is possible, flexibility and adaptability, and also it is scalable. But there are disadvantages, and these include difficulty in determining the optimal number of clusters, sensitivity to initial conditions and noise, interpreting results, and also the validation of cluster quality. It can be quite a challenge. And the next category of unsupervised learning that we are going to look at is dimensionality reduction. What is it? It is actually a process of reducing the number of input variables. And remember, in our supervised learning, we had features, independent features, and now we're just talking of features or columns or independent variables in a data set. It is particularly useful for simplifying data, visualizing patterns, and improving model performance. Why is it important? It is important because it reduces computational cost, improves performance of clustering algorithms, helps with data visualization, and removes multicollinearity and noise in the dataset. The dimensionality reduction algorithms are divided into two major classes, and these are the ones which are used for feature extraction and others which are used for feature selection. We'll look at those which are used for feature extraction. This include the principal component analysis, T-distributed stochastic neighbor embedding, uniform manifold approximation and projection, and also autoencoders. The principal component analysis is a linear technique that projects data to a lower dimensional space while preserving as much variance as possible, widely used for feature extraction and visualization. Then we have this distributed stochastic neighbor embedding, which is TSNE. It's a nonlinear technique that preserves local data structure by modeling similarities between data points. And then the uniform manifold approximation and projection, UMAP, is also similar to TSNE, but faster and better at preserving both local and global structures, commonly used for large data sets. Then we have autoencoders. These are neural networks trained to reconstruct the input data with a bottleneck layer that forces the network to learn a compressed representation. For feature selection algorithms, I selected the following. They are not the only ones, but I selected the high correlation filter, which removes highly correlated features as they are redundant. Then we have the random forest, which uses a random forest model to determine feature importance and select the most relevant ones. Backward feature elimination, which starts with all features and iteratively removes the least important ones. Whereas the forward feature selection does the opposite. It starts with an empty set and iteratively adds the most important feature. The applications of dimensionality reduction is in visualizing clusters, noise reduction, pre-processing of clustering or classification, data, feature engineering, and data compression. Advantages include faster computation is achieved, better visualization, and prevention of overfitting. The disadvantages of dimensionality reduction include loss of interpretability, risk of oversimplification, and the difficulty in choosing the number of dimensions. Now we'll look at the association rule mining. This is an unsupervised learning technique used to discover interesting relationships or associations between variables in large data sets. The core idea is to identify if-then relationships, often expressed as rules that indicate the co-occurrence of items or events. There are three key algorithms: the a priori, ECLAT, and the FP growth. The a priori is a classic algorithm that identifies frequent item sets and then generates associated rules based on these frequent item sets. It uses a pruning strategy to efficiently reduce the search space. The ECLAT is an alternative to a priori, using a depth-first search approach and vertical data format for efficiency, especially with large data sets. Then the FP growth algorithm. It utilizes a tree-based data structure, FP tree, to store frequent item sets, offering efficiency for sparse data sets by avoiding candidate generation. We can apply these algorithms in the following use cases. That's for basket analysis or recommender systems, medical diagnosis, business intelligence, and also in data mining. There are advantages that comes with these algorithms. They can discover hidden patterns. There's no need for labeled data, and they can produce actionable business insights. The disadvantages include the difficulty in scalability and computational complexity, choosing appropriate metrics and thresholds, rule explosion, handling noise and outliers, dealing with missing values. It's a challenge. The interpretability and actionability is also a challenge. Well, in this lesson, we can say we have learned, just got an overview of what unsupervised learning is and where we can apply unsupervised learning. And we saw that we can apply supervised learning in customer segmentation, whereby we are grouping customers by purchasing behavior. In fraud detection, where we are identifying abnormal transactions. In news categorization, clustering articles by topic. Image compression, that's when you're reducing image data via PCA, and also in social network analysis, whereby you're finding communities that are simpler in graphs. In summary, in unsupervised learning, you don't need any labels, only input features, no outputs. Main goal is pattern discovery or similar groups in the dataset. The key techniques we covered is clustering, dimensionality reduction, and association rule mining. The use cases, the prominent ones or major ones, is segmentation, anomaly detection, and compression. Thank you very much for your listening. We will meet in the next video.